Welcome to the DIY Honda Garage channel. In this troubleshooting guide, we will explore the diagnostic trouble code DTC P2270, which signifies a malfunction in the secondary heated oxygen sensor HO2S circuit. This code indicates that the signal from the secondary HO2S sensor is consistently reading lean. The secondary HO2S is essential for monitoring the exhaust gases and providing feedback to the engine control module, ECM, for optimal fuel control. Location-wise, the secondary HO2S is typically positioned in the exhaust system after the catalytic converter. If the ECM detects that the sensor remains in a lean condition, it triggers the P2270 code. Such issues can lead to decreased fuel efficiency, increased emissions, and can even trigger potential engine misfires if left unaddressed. It's crucial to diagnose and resolve this issue promptly. The secondary heated oxygen sensor, often referred to as secondary HO2S, is instrumental in managing vehicle emissions. Its primary role is to measure the oxygen content in the exhaust gases, which allows the ECM to optimize the air-fuel mixture for combustion. This component is typically situated after the catalytic converter in the exhaust system. By monitoring the exhaust gases, it ensures the catalytic converter is functioning effectively, which is vital for reducing harmful emissions. If the secondary HO2S detects that the mixture is lean, it signals the ECM to make adjustments to the air-fuel ratio. A malfunctioning sensor can lead to improper fuel mixture adjustments, resulting in poor engine performance and higher emissions. Understanding this component's role and location is essential for effective troubleshooting. There are several possible causes for the P2270 code, beginning with a faulty secondary HO2S itself. Over time, sensors can become damaged or wear out, leading to incorrect readings. Another significant cause might be poor connections within the wiring harness, which could impede proper communication between the sensor and the ECM. Additionally, it's essential to consider loose terminals at both the secondary HO2S and the ECM PCM, which can create intermittent faults. Each of these factors can lead to a lean reading, prompting the P2270 code. Diagnosing these elements is crucial to effectively resolving the issue, ensuring the entire system functions as designed. When dealing with the P2270 code, there are several symptoms that may manifest. The most common are the illumination of the check engine light, CEL, indicating that the vehicle's onboard diagnostics have detected an issue. You might also notice poor engine performance, as a lean condition affects how the engine runs, potentially resulting in hesitation or stalling. Furthermore, increased emissions can occur, which exacerbates environmental concerns and could lead to failing emissions tests. Drivers should be aware that ignoring these symptoms could lead to more severe engine issues down the line, making it essential to act promptly upon recognizing them. The first step in troubleshooting DTC P2270 involves turning the ignition switch to the on position. This ensures that all vehicle systems are powered and prepares the onboard diagnostic system for data collection. At this stage, it is essential to record any freeze data, which captures vehicle parameters at the time the DTC was triggered. This information can prove invaluable in diagnosing persistent issues. Following the recording of freeze data, it is important to clear the error code using the Honda Diagnostic System, HDS. Clearing the DTC resets the system and allows a fresh start for testing. Taking these initial steps sets the stage for more targeted diagnostics based on the newly cleared status. In the second troubleshooting step, start the engine and maintain an engine speed of 3,000 RPM without any load. This means shifting the automatic transmission to to park or neutral for manual transmissions. This process helps simulate operating conditions while ensuring that engine performance can be accurately monitored. It is critical to hold this speed until the radiator fan activates, which typically signifies that the engine has reached a specific temperature threshold. This step is crucial, as the engine's performance at different RPMs and temperatures will directly impact the sensors being tested. Monitoring these criteria prepares the diagnostic system for subsequent tests. For the third troubleshooting step, it's essential to take the vehicle on a test drive under specified conditions. Specifically, ensure that the engine coolant temperature, indicated by the engine coolant temperature sensor 1, remains above 158 degrees Fahrenheit, 70 Celsius. Proper temperature levels are critical as they affect sensor functionality. During the drive, maintain the vehicle speed within the range of 1,500 to 3,000 RPM and ensure the automatic transmission is in drive or the manual transmission is in fourth gear. This allows for effective monitoring of sensor signals under real-world operating conditions, which is instrumental for determining the vehicle's responsiveness and whether the P2270 issue persists. In the fourth step, using the Honda Diagnostic System, HDS, monitor the onboard diagnostics, OBD status for DTC P2270. This diagnostic tool provides real-time feedback on whether the DTC is currently present. Should the HDS indicate a failed status, we proceed to the next step in the troubleshooting process. However, if it shows past or an intermittent failure, it's likely the system is functioning normally at that moment. Nonetheless, checking for poor connections or loose terminals at the secondary HO2S and the engine control module ECM is warranted. If the HDS indicates not completed, it's crucial to recheck and possibly repeat the earlier steps to further diagnose the issue effectively. The fifth troubleshooting step involves first turning the ignition switch to the lock 0 position. This action is important to ensure safety before replacing any components. Next, replace the secondary HO2S as it has shown faulty behavior in previous diagnostics. This sensor is vital for ensuring proper air-fuel ratio and vehicle emissions control. Once the sensor has been replaced, turn the ignition switch back to the on 2 position. This prepares the vehicle systems to recognize the new port and initiate the next steps in the process. By replacing the faulty sensor, we aim to resolve the issue indicated by the DTC. In the sixth step, after replacing the secondary HO2S, it is crucial to reset the engine control module, ECM, or powertrain control module, PCM, using the HDS. This reset clears any outdated information that may hinder the interpretation of new sensor data. After resetting the ECM, PCM, perform the idle learn procedure, which allows the system to recalibrate and adapt to the new conditions. Following these procedures, start the engine and maintain its operation under the previously described conditions. This step is essential as it ensures that the ECM has updated information regarding engine performance, facilitating further diagnostic checks and ensuring smooth engine operation. The seventh troubleshooting step involves a repeat procedure of holding the engine speed at 3,000 RPM without load until the radiator fan activates. This serves to imitate previous conditions and allows for consistency when diagnosing the sensor behavior post-replacement. This step is crucial for confirming that the newly installed secondary HO2S is functioning effectively, as it should send accurate signals to the ECM under the specified conditions. Once this has been achieved and the fan has activated, allow the engine to idle. This provides an opportunity to monitor the system's performance closely and verify the effectiveness of the repair. For the 8th step, perform another test drive under specific conditions similar to previous tests. Ensure the engine coolant temperature sensor 1 indicates a temperature above 158 degrees Fahrenheit, 70 degrees C, to ensure the engine is adequately warmed up for testing. During this drive, keep the engine speed between 1,500 and 3,000 RPM, while ensuring to gear the automatic transmission in drive or manual in 4th gear. This simulates real-world conditions and verifies the operation of the vehicle under typical driving situations. It's crucial to observe how the engine and newly installed sensor behave during this process, focusing on responsiveness and stability. In the 9th step, use the Honda Diagnostics System, HDS, to check for any pending or confirmed DTCs. It is essential to verify whether the P2270 code has reappeared after the repairs have been made. If the HDS indicates the presence of the P2270 code once more, it is a strong indicator that further investigation is necessary. This might lead to checking all connections and terminals at the secondary HO2S and ECM/PCM to ensure there are no loose or poor contacts. Once these connections are verified, you should revisit previous diagnostic steps for additional examination. Tracking the presence of the DTC helps to ensure a thorough resolution of the issue. In the final troubleshooting step, monitor the OBD status using the HDS for DTC P2270. This check provides a clear status report on whether the code has cleared or persists. If the HDS indicates passed, it signifies that troubleshooting is complete and no further actions are required at this moment. Should there be any other pending or confirmed DTCs indicated from previous steps, refer to those specific codes for further troubleshooting. Conversely, if the HDS indicates failed for P2270, it is critical to re-examine the connections at both the secondary HO2S and ECM/PCM. If the status shows not completed, review prior procedures to ensure nothing has been overlooked. This concluding check confirms whether the DTC resolution was successful. Final repair verification is a pivotal step in ensuring that all issues related to DTC P2270 have been comprehensively addressed. After following the troubleshooting steps and making necessary repairs, confirm that the vehicle's systems are stable without further error indications. Using the HDS, check for confirmed and pending DTCs to validate that the P2270 code is not present anymore. This step ensures that not only is the originally suspected sensor functioning, but the entire exhaust system and associated sensors perform optimally. Be sure to review any other codes that may have arisen, as they could indicate further underlying issues. Confirming successful repairs is critical for promoting long-term vehicle reliability and performance. Preventive maintenance is essential in minimizing the chances of encountering issues like DTC P2270 in the future. Regularly checking the function of the secondary HO2S and other related sensors can preemptively catch any faults before they escalate. Additionally, conducting periodic inspections of all connections, both at the secondary HO2S and the ECM/PCM, ensures that any potential wear or disconnections are addressed promptly. Keeping the exhaust system clean and free of blockages significantly enhances sensor performance and longevity. Implementing these maintenance practices fosters an overall healthier engine environment, minimizing potential emissions and performance-related issues. In conclusion, understanding DTC P2270 is crucial for maintaining optimal vehicle performance and compliance with emission standards. The comprehensive troubleshooting steps outlined in this guide provide a clear pathway to effectively diagnose and remedy issues related to the secondary HO2S circuit. Recognizing the symptoms and potential causes empowers vehicle owners and technicians to approach repairs with confidence. Additionally, highlighting the importance of preventive maintenance underscores the need for routine checks and care to prevent future occurrences of similar issues. By adhering to these guidelines, vehicle owners can significantly enhance the longevity and efficiency of their Honda Accord models. Please like and subscribe to the channel. See you next time!